excited to present this topic to you all. Equilibrium in terms of forward and reverse reaction. First, let's talk about what reactions are. In chemistry, reactions happen when substances come together and change into new substances. These changes can be described as forward reactions, where reactants become products. Now, in real life, many reactions don't just go one way. They can also go in reverse, where products become reactants again. This is called a reverse reaction. When a reaction and its reverse reaction happen at the same time, we say that the system is in equilibrium. At equilibrium, the forward and reverse reactions are happening at the same rate, so the amounts of reactants and products stays the same. Now here are the key concepts that will help us understand equilibrium in terms of forward and reverse reaction. The law of mass action. The law of mass action explains how the rates of forward and reverse reactions are directly related to the concentrations of reactants and products. This principle states that the speed at which a reaction occurs depends on the concentrations of the substances involved. This concept is crucial in understanding how reactions reach equilibrium and how changes in concentration can affect the position of equilibrium. Equilibrium constant, or Kc. The equilibrium constant, or Kc, is a fundamental concept in chemical equilibrium that provides insights to the position of equilibrium for a given reaction at constant temperature. This value helps determine the extent to which a reaction favors the formation of products or reactants at equilibrium. Understanding the equilibrium constant is essential for predicting the direction of a reaction, calculating concentrations at equilibrium, and optimizing reaction conditions for desired outcomes. Now let's move on to dynamic equilibrium. Dynamic equilibrium describes a state where the rates of the forward and reverse reactions are equal, allowing both reactions to continue to occur at the same rate. This balance between the forward and reverse reactions results in a stable system where the concentrations of reactants and products remain constant over time. Dynamic equilibrium is a dynamic process where reactions are ongoing, but the overall composition of the systems does not change. The reaction quotient, or Q, is a measure of the relative amounts of products and reactants present during a reaction at any given time. It is calculated using the concentrations of reactants and products raised to the power of their stoichiometric coefficients in the balanced chemical equation. The reaction quotient can be compared to the equilibrium constant, or K, to determine the direction of the reaction that is taking place. If Q is greater than K, the reaction will proceed in the reverse direction to reach equilibrium. If Q is less than K, the reaction will proceed in the forward direction to reach equilibrium. If Q is equal to K, the reaction is already at equilibrium. By understanding the reaction quotient and its relationship to the equilibrium constant, chemists can predict the direction of a reaction and determines whether a reaction is at equilibrium.